All right, Math 1 friends. Here we are with another Ready, Set, Go video. This one is supposed to help with 3.2. And we kind of decided that we're not going to focus on this get ready for right now, okay? What we're going to do is we're going to immediately jump to the get set. And the reason is because in this lesson, in 3.2, we learn about this idea of interval notation and having to explain all these new things. So we really want to focus in on this. So with that in mind, we're going to skip ahead just a little bit. We're going to look at the get set, and we see that when we go through this module, we're going to need to describe certain features of functions, such as the intervals where a function is increasing, decreasing, or constant. I want you guys to understand when I say the word interval, I kind of mean sections, okay? I want you to think about it as sections. Now, sections of increasing, decreasing, constant. Then, we do want to know about minimums and maximums, so that's low point, high point, kind of what we would think. I maybe should say points, right? Because it could happen more than once, so just so we know that. And then the idea of domain and range could be a little bit new. Idea of domain is basically all the x's, whereas range is all the y's. Alright, so these might be some new ideas. And then even more that's new is this idea of interval notation. So we ask the question, interval notation? Well, this idea of interval notation is a way that we're going to describe an interval or a section, okay? And so when we think about interval, we say an interval is a set of all the real numbers between two numbers, a lower bound and an upper bound. And so what I want to do is actually think about something that we talked about back, I think maybe in Module 2. And what I'm going to do is I'm going to sketch a little number line. Alright. Now, I know some things. If I want to make a list of all real numbers between 2 and 4, well, I can start with 2 and I can start with 4. But then what are some other numbers that are between? Well, the very easy and obvious one I would say is maybe 3, so I could put a dot there. Another kind of obvious one maybe is right here at 2.5, right? I went between 2 and 3. I could keep splitting the middle, right? I could go halfway. But what I'm trying to get at here, like I could keep making all of these dots and dots and dots, and what I need you guys to understand is I could do that forever. There are an infinite number of points between 2 and 4. An infinite number, okay? I can't list them all. I can't do it. We cannot make a list. We cannot make a list. It's impossible. And so what we do is we use interval notation. What I'm going to do is I'm going to put my boundaries. So one of my boundaries is 2, the low boundary. My upper boundary is 4. I put a comma between to separate them. And because I'm including the 2 and the 4, I'm going to use this idea of a bracket, okay? And actually, I should be a little more specific, okay? Right? I'm including every single point, so technically I would need to make this every point between. I'd have to kind of shade it in nice and dark so I know I'm talking about every single location between 2 and 4. Okay? My bad about that. And so again, what were these points? 2 was my low bound. 4 was my actually, you know what? I'm going to use the word upper bound. And the fact that I used the square brackets, okay, I use the square brackets because I include boundaries. Alright, include boundaries. Sorry, I'm lefty, so hopefully you can see that now. I'm including the boundaries, so I use square brackets. Okay? So, with this in mind, this idea of interval notation, understanding low bound, upper bound, and then kind of this new idea of boundaries or brackets, brackets, we're going to answer some questions on the next page. So, before we even try this whole interval notation stuff, let's first talk about what it really means to be increasing, constant, decreasing. I think you guys probably have this, but just in case, I'm going to talk about it. If I want the intervals of increasing, well, I want these sections where my graph is doing what? Going up. Notice I kind of sketched it angled, right? We have to remember when we're doing these problems, we always need to consider that we're going positive in the x direction, okay? So that's why I went positive in the x and I went up in the y. Well, intervals were constant. What would happen? I wouldn't go up or down. I would just stay straight to the right. And then the last idea is decreasing. So I hope with this idea you would actually be able to kind of answer some of these already. I'm going to highlight in blue, so if you have a highlighter, feel free to pause and grab it. I'm going to highlight my intervals of increasing in blue. And so to me, I would say right here, right? I'm going down, 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 down. Oh, then I skip some places. And then right here, what's happening? We're going straight across, and then finally, right here, right there, it goes up. So I'm going to highlight that in blue. And then we skip some, and then what's going on here, guys? This one's tough. This definitely is clearly going up here, 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 here. But I need you to understand, I know it looks like it gets flat, but I need you guys to kind of think about this. We talked a little bit about this in Module 2. Even when this is getting really, really close to the x-axis, it's still getting closer and closer. There's always a space from this point that's closer to zero, closer to zero, closer to zero. Even though you can't tell, this thing is still increasing just a very little bit. So that's an idea that you might need to practice a little bit. So now that we've talked about increasing, let's talk about constant, where our graph stays constant, where we're not going up or down. Well, let's think. What about right here? No, we're going down here. We're going down, but then, ooh, right over here, we're going straight. We're not going up or down. And so I would highlight that little section pink. Now, I think we should maybe be kind of straightforward here. Where are we decreasing? Well, we're decreasing as we go down to the right. And so this, I would say, is here. Now, please be careful. There's an arrow going up, right? That means that technically we're going down. Down, 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 forever over here, even though we're off the paper. Okay? Okay. So now that we kind of can see these sections, we need to be able to list them. And remember from before, we have our square brackets. We need to know that square brackets mean, we call them closed. And what I really mean is that the boundaries, are included. So I'm actually going to show you, or give you another option that we're going to see in a little bit. If I don't use brackets, I can always use parentheses. Now it could be confusing with a point, but we use these, we say it's open. And what I mean by that is we still have the same boundaries, but we think about it just a little bit inside of it, all right? We don't actually include it. So boundaries, aren't included. Okay? And so now with that in mind, let's take a little bit of a look here. Oh, you know what? I want to do one more thing. This was a great idea that I liked from Miss Burko that I want to add. You know how we have these arrows that are going up and to the left forever, and here we're getting really, 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 really close to zero, but it's going on forever and ever and ever in the x direction? I want us to think about this. I know this is just a snapshot of a graph. What we need to know is this grid, this paper goes on forever and ever and ever and ever. And so what we also need to kind of teach you guys is this idea of infinity. All right, this is the infinity symbol. You guys have probably heard about infinity, right? Buzz Lightyear to infinity and beyond. Infinity is an idea. It goes on forever and ever. You can always go a little bit farther, right? That's the idea. Well, if we're going up, well, then we can go to positive infinity. If we're going down, we can go to negative infinity. Same thing in the x direction. If I'm going right, these are positive numbers. I could go positive forever and ever and ever. And then I could also go negative forever and ever and ever. So this is something I'm going to add because we're going to need to know this when we go to our intervals. So here we go. Let's get to the hard stuff. Let's get to the tricky stuff. The sections, or the intervals where we're increasing. Well, we know that it's the blue ones, right? So from right here, at this x value of what? Let's see. Oh, -2. That's my lower boundary. My upper boundary is what x value? And I should have been more clear. We're talking x values here, guys, okay? The intervals of increasing always have to do with x values. X values. So the x value over here would be a +2. And this is where we go to the idea of open or closed. We need to put the right parentheses or brackets on this. And what I'm here to tell you is, when you have a filled in circle, right here, we say it's included. We can actually have that point. All right? Because that's filled in, there is an actual point at, what is that, 2, 3. So what I do, if there's an actual point there, is I put a closed bracket there. Same thing here. There's an actual point here at -2. So again, I put a closed bracket. Okay? I think maybe you can see we're gonna not jump there right ahead, but this is going to be something that we're going to talk about in a little bit. We do have another section though. So I'm going to put a little comma here. And then we also have to describe this other section over here, okay? Now here's that idea, what this is going on forever and ever to the right, okay? So we know that this thing is picking up at an x value of 1, 2, 3, at 4, okay? I have an x value here of 4. So I know my lower boundary of this section is at 4. My upper boundary, oh man, it goes on forever. Technically, there really isn't an upper boundary. It goes on forever. And so here's a couple of things you got to think about. This was a closed circle. So 100%, because it was a filled-in circle, I'm going to have to put a bracket by the 4. It's closed. It exists. There is an x value there. We can't ever reach infinity. Again, it's that idea, guys. We can't ever get there. And so what we will always use with an infinity is a parenthesis. That means it's open. We don't, it's not included, right? Because we can't ever get there. All right? With that in mind, let's take a look at our next one. All right, interval where constant. Okay, so let's start by getting the lower and upper bounds. Again, x values. -1, -2, -3. Okay, -4 is my lower boundary of the pink. -2 is my upper boundary of the pink. But do you guys notice how there's an open circle there? It's not filled in. What that's telling me, guys, is there's not actually a point there. I can get super close, but I can't actually ever get to -4 as an x value. I could get to like -3.999999999999999 and on and on and on, but I can never get to -4, excuse me. And so we put an open, a parenthesis. It can't ever reach -4. However, on the other side, oh, there's a point there, right? And so, once again, similar to our other ones, we use a closed bracket because there's that point there. Okay, last section. Interval of decreasing. Interval of decreasing. Okay, I'm going to start with the easy one. I would say I know my upper bound, my upper x value. My upper x value is -6. So I'm going to put in -6 as my upper boundary. But I know I need to find the lower boundary. Now let's take a look. Oh, it's going to the left forever. So what did we say when it goes left, or when it kind of has that idea of going on and on off my grid, even though my grid keeps going forever and ever? Well, that means that the lowest x value is actually, oh, negative infinity. And once again, because we can't ever reach negative infinity, we use an open or a parenthesis. What about at the negative 6, though? Pause it, quiz yourself. I hope you said that it was closed, because there's a filled in dot at negative 6, comma 3. Okay? Now, let's move on to a new concept, minimum, maximum. Minimum and maximum are basically, can we find a minimum value? Can we find a minimum value? When I look at this, is there a place on my graph where I can find a surefire number that is my lowest or smallest y value? And I should be more specific there. This is a y value. Y value. And I hope you agree with me when I say absolutely yes, right? From here, there's no graph, no graph, no graph, no graph, no graph, and then all of a sudden, wait, our graph picks up right here. This point right here is our lowest point, correct? And it occurs at a y value of negative 1, negative 2, negative 3, negative 4. So, I say yes. I say that the value is negative 4, and here we go. I need you guys to be very careful here. I'm going to say negative 4, and it's at x equals, where does it occur? It occurs at x equals 1, 2, 3, 4, at x equals 4. Okay? The lowest value, when we just ask you for the value, we really want the lowest y number, but a lot of the times when we ask you that, we also want to know like at what x value it's occurring at. Okay? Let's look at maximum here. This is interesting. So we knew this was the lowest. We could go up our graph. This kind of tails and goes kind of closer to 0 forever. Then we miss some places. Oh, it picks back up here. And then what do we notice? There's an arrow. This thing goes up and up and up forever and ever. So we think positive infinity. But do you remember what we said? Can you ever reach an infinity? No, you could get as close as you want, and you can always go a little further. And so guys, with that in mind, we actually say, no, there's no maximum here. And again, if we make a little note, you can always go a little farther, right? You can always go a little farther. You think you get to infinity and nope, you're not there. There's more to go. Okay? Cool. So now we have intervals. We have this idea of minimum and maximum. Let's chat domain range. We might as well. I would say this might be the toughest part. All right? This again is going to get back to our interval notation. And what we have to remember is domain of a graph or of a function is all x values. And so what I like to do, I don't know if you want to do it, but to me it's a little helpful. Either grab a piece of paper or maybe just a pen, something that you have handy, a ruler perhaps, an ID. And what I want to do is I want to take something and I want to figure out everywhere where I have a point, and by that I mean I want all the x values, where there's a point. So think about this. I'm picking up right here, but there's an arrow, right? So already, technically, I have an x value, right? There's going to be an x value from negative infinity to here, 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 right? There's a point, right? There's a point, there's a point there, point there, point there, point there, point there. And then what happens is I get to the right side of this point. There's no graph. Okay? So, with that in mind, we know that there's domain. There are x values everywhere from here and to the left. And so I'm going to start by putting that in my domain. That should actually be very similar to our intervals of decreasing. That's one thing that could really help you. Using some of your intervals to help you with domain. So I know that this section, the decreasing section, is my first section of my domain. Now, there's more though, right? That's just the first part. Now notice what happened. Oh, right here, there are no points. There are no x values, right? From here to here, I lose it. I lose a graph. There's no points. And so we pick back up here at -4, and then we go until, what is that? Oh, 2. All right, so now I have another section of domain. I have another section where there's x values. So I'll start by putting my boundaries, -4 and 2. Please be careful. We have to use our correct brackets. Because this is open, is there technically a point there? I hope you said no. Parenthesis at the -4, closed bracket at the 2. No point here, point here. So no x value, yes x value. And lastly, okay, we had one more section. What's going on here? Oh, so my bad. After 2, right here at a little past 2, there's no point, and 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 no point, until right here at x equals 4, there's a point again, and then there's a point forever and ever and ever because of the arrow. And so I know that I just have to describe this last section, and I'll be done with my domain. Well, it starts at 4. It goes forever to the right. Is there a point at x equals 4? Absolutely. And remember, we can never ever reach infinity. Whew! Yikes. That gets tough. We also didn't give you a very easy one to learn this stuff. That's my bad. Guys, range is exactly the same. Okay? Range is exactly the same, however, what? What are we changing? The way we're looking. Alright, we're not going left-right anymore. We're not going left or right anymore. We're going up and down. Sorry, down to up is how I should say it, okay? We're going down to up. So here again, grab something that you like, a pen, a pencil, an index card, an ID, a ruler, something. And what I'm going to notice here is that I have no graph right here, right? If I continue down my grid, right? If this grid goes over and over and over, there's nothing here until what y value? Oh, right there, -4 is my first y value. Okay? Now notice there's a point here, 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 and then what's going on because this arrow is going to the right, and it's, sorry, not to the right. Well, yeah, it's going to the right. Is it ever reaching 0? No, it's never going to touch the x-axis. So what's going on? What's going on is this. My y values begin at -4. They get really, really close to 0. But because they never ever hit, I have to put an open parenthesis on the 0. And because there's a point at a y value of -4, I have to close the -4. Okay? Now, that's just part. Right after this, what happens? We jump up. We miss everything, right? There's nothing between 0. Oh, I'm off the paper. You guys got to tell me. Oh, wait, it's a video. There's nothing between 0 and 1, right? But right at 1, oh, there's y values again, okay? As long as there's one y value, it counts. I know there's an open circle here, but because all of these other places have a y value of 1, it counts. So now, from 1 until, let's see, yep, there's a point, 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 there's a point. And guys, guess what? Even though right here, there's no more, like this line goes away, sorry, this little chunk goes away over here, guess what? It immediately picked up on the other side. And so there's still y values everywhere, from 1 up to 2, up to 3, and then forever and ever because of our other section of the graph. So my next section would go from 1. How do I go up forever? Positive infinity. Now again, was there a y value of 1? You're darn right there was. So I have to bracket my 1. But I can never, ever, ever bracket a parenthesis. I can never, ever bracket an infinity because I can always go a little farther. Now, I know this video is getting long, so I'll cut this next part kind of short. X-intercepts, where we cross the x-axis. Y-intercept, where we cross the y-axis. And so, if we notice x-intercept, I literally just look along the x-axis. Are there any places where my function actually touches the x-axis? Remember, this thing is getting really, really close to 0, but it never touches. And so what I'm going to say is, nope, there are no x-intercepts here. My graph never hits the x-axis. Okay? In terms of the y-intercept, same idea, but now we're looking at the y-axis right down the middle this way, and I hope you guys agree with me. It hits right here. The point right here where it crosses the y-axis is 0, 2, and so I will list that as my point. Okay, so this video was entirely too long. I hope you guys were able to double time it or rewatch the little sections in terms of what you need. I hope it wasn't too crazy. And again, please make sure that you're talking with your teachers and really getting this stuff figured out. It's good stuff, it's important stuff, and you guys are going to do great at it if you keep working. I hope you have a great day. Bye.